Hey guys, machining tapered walls either in a pocket, especially a deep pocket, or a standing core can be time consuming and challenging if you don't have the right tools, cam package, and approach. What we're going to show you today is a special application. We've got a pocket here that goes 4 inches deep and it's got 1 degree tapered walls. So a traditional end mill is not a good approach for this. We need something that's adept at finishing very tall walls, whether they're straight or tapered. The technique we're going to teach you today is called plunge finishing. And what this does is, instead of executing a profile cut and stepping down in Z very gradually to get a nice finish, we're actually going to use Z axis to plunge up and down using a bullnose type cutter. Now this is DAPRA's SBD insert, and it's a backdraft insert with just a corner radius and a small wiper. It's designed to reduce tool pressure when you're doing wall finishing like this. Generally, a lot of our customers profile mill with this tool, which works just great, but if you're trying to achieve a fine finish and you program a small scallop height into your CAM software, it's going to take a lot of passes to get all the way down to the bottom, which means a lot of time. What we're going to do is plunge finish using Z-axis motion and creep feed our way around the profile. That's going to mean that the scallop height that the CAM package uses, instead of being dictated by the corner radius on our bullnose cutter, is going to be dictated by the cutting diameter of our tool. That means a much larger step over, which means shorter cycle times. So we'll show you that. But obviously, before we finish this pocket, we have to get the material out of the way. So one of the things we'll show you today is a process called high feed ramping. And you'll see that even in a pocket of this size, which is 5.5 inches long, 3.5 inches wide, and 4 inches deep, using high feed ramping, we can remove this material in less than 10 minutes. We're not using a 50 taper machine with 40 horsepower, by the way, to do this. We'll run this whole program on our 40 taper Haas VM2. So get ready, you're in for a treat. Okay, so we have a piece of 4140 pre-hard, 8.25 inches long by 6.25 inches wide by about 5 inches high. And within the block we have a pocket we'll be machining, both rough and finish. The pocket has a length of 5.5 inches, a width of 3.5 inches, and a depth of 4 inches. And the pocket walls all have a 1 degree taper, so this requires some sort of special finishing approach other than a regular solid carbide end mill. So what I have programmed in is, for the roughing part of this, is high feed ramping. So I have a 2-inch cutter diameter with a special program radius, a feed rate of 270 inches a minute, feed per tooth of 40 thousandths, and a surface footage of 700. And using ramping at a depth of 30 thousandths per pass in this program to keep our chips smaller. We'll ramp continuously down the pocket walls, leaving 10 thousandths stock on the wall. And we'll take that actually to a depth of 4.25 so that our high feed roughing is a little below our 4-inch deep finishing pass. So we're good with that. And then the typical finishing approach that's taken for a pocket like this is to use a bullnose type cutter and do what some people call a racetrack or a waterline technique that basically just follows the contour of the rectangle and steps down in Z with each pass to create a finish. So what we're using is a 1-inch bullnose with a 1/16 corner radius. A feed rate of 70 inches a minute is 10 thousandths feed per tooth at 900 surface feet or 3,400 RPM. Our parameters are set up to go leave no finish stock, obviously, because this is a finished cut, but the scallop height is the critical component here. We're going to program this to leave a 1/10 scallop so that we have a fine finish with minimal polishing necessary. So the tool path then will show us what that is involved or what time is necessary to rough and finish this pocket using this approach. So we'll start with the high feed ramping. And again, this is a 2-inch cutter. And you'll see it's just traversing the periphery of the pocket with a constant downward motion in Z. And we'll speed this up a little bit to get to the bottom. It's a fairly deep pocket. And the biggest challenge here is going to be chip evacuation. This is a relatively deep pocket at 4 inches, and machining this on a vertical machining center, we're going to want to have a really good air supply involved blowing those chips up and out of there. That's actually why I went with a 30 thousandths ramp instead of a 40 or a 50 thousandths ramp. It really has more to do with evacuating those big heavy chips than it has to do with the cutter's capabilities. Okay, so we're near the bottom. All right, it's just about there. All right, so now we're into the finishing routine. Let me slow this down just so you can see what the cutter's doing. So this is the typical approach for finishing tapered walls. The cutter just executes the profile over and over and over again, stepping down slightly in Z with every pass. Now again, with a 1-degree tapered wall, the CAM software is executing a routine that's going to generate a 1/10 scallop on the wall. So it's calculated the step down per pass to match that 1/10 scallop. So now let's let this wind its way through the tool path and get to the bottom. You can see that happening. And once we get to the bottom, we see we have a total cycle time of 2 hours and 17 minutes. So using the traditional approach of roughing and then waterline finishing, we have a cycle time of 2 hours and 17 minutes. All right, so now let's take a look at a more aggressive approach to this. We'll still rough our pocket out using the high feed ramping technique that we used in the previous example, but for our finishing this time, I'm going to go to a plunge finishing technique. Now in Mastercam, I'm still using a finish flow line routine. Still using my 1-inch cutter with a 60 thousandths corner radius. And I'm running the same feeds and speeds, and that's very important, as we used in the waterline finishing, 70 inches per minute, 3,400 RPM. But what I did in defining my surface geometry was I dictated that the tool path be vertical rather than race tracking or horizontal around the profile. And in my finish flow line parameters, I'm still designating a scallop height of 1/10. So nothing has changed with the tool as far as the scallop height or the speeds and feeds. So select the roughing and then select the plunge finishing approach, and now let's see a verification of these two methods combined and see how the cycle time compares to the previous approach. All right. Start with our roughing. And let's speed that up because we've seen this. And keep in mind with the roughing that your high feed tool needs to be adept at ramping to use this approach, and you need to use a good tough grade of carbide. Okay, so now here's what the plunge finishing looks like. And if any of you have ever seen jig grinding, you'll notice that this is very comparable to that. The tool is literally plunging up and down the wall and creeping its way around the profile as it works. Now, one of the beauties of this and why it really is so much faster is that your scallop height of 1/10 is now being determined by the 1-inch diameter of your cutting tool, whereas in the previous approach, the waterline approach, the step down was determined by the 60 thousandths corner radius on the bullnose cutter. So notice the difference. On the step down, the 60 thousandths corner radius dictates or generates your scallop. But when you're stepping over, as the plunge finishing technique uses, your scallop height is controlled or dictated by the 1-inch diameter of the tool and how much you step over with that. So since your 1-inch diameter is so much larger than the 60 thousandths corner radius, the step over is much greater. Consequently, we have a total cycle time of 54 minutes to rough and finish this pocket. Now compare that to over 2 hours and 15 minutes with the traditional approach, and you see this is a fantastic time saver. Okay, so that's how it's done. High feed ramping to quickly remove the material inside our pocket. The same approach can be used for removing the material outside of a profile as well. Then, once the material was gone, we semi-finished and finished using our SBD bullnose type cutter. Now it's important to note on that semi-finished cut, all of the cutting was done in a downward direction with a rapid retract. When removing more material, especially on a long length to diameter ratio, it's best to keep the cutting in the downward motion. But when we transferred to the finished cut, where we were only taking 5 to 10 thousandths per side, it worked just fine to finish on the way down and on the way back up. So plunge finishing, 55 minutes, profile finishing, 2 hours and 10 minutes. Which will you use?